Chapter 5 for CIST 2612 covers working with Windows and CLI systems. In this chapter, we're going to look at the purpose and structure of file systems. We're going to look at Microsoft file structures, look at the structure of NTFS disk. We'll list some options for decrypting drives encrypted with whole disk encryptions. We're going to look at the window registry and how it works. Microsoft startup tasks will be discussed, and also explaining the purpose of a virtual machine. All right, we'll start out with the file system. File systems gives an operating system a roadmap to data on the disk. Now, the type of file system that an OS uses determines on how the data is stored on the disk. So, file system is the way the files are stored on the disk, and it gives the operating system a roadmap to data on the disk. When you need to access a suspect's computer to acquire or inspect data, you should be familiar with the computer's operating system and the file system as well. CMOS is our complementary metal oxide semiconductor. You want to make sure that you don't contaminate or alter data on a suspect's system. So you must know how to access and modify a PC's CMOS, BIOS, extendable firmware interface, and unified extensible firmware interface settings. Now, what the CMOS does is a computer stores the system configuration and data and time, date and time information in the CMOS when the power to the system is off. Our BIOS, or basic input-output systems, and our extensible firmware interface, EFI, that contains the programs that perform input and output at the hardware level. Now, when a suspect's computer starts, you must make sure it boots to a forensically configured CD, DVD, USB device, because if it's booted to the hard drive, it overwrites and changes the data. The bootstrap process is contained in ROM that tells the computer how to proceed when booting. It displays the keys you press to open CMOS setup screen. CMOS should be modified if you want to boot from a CD or DVD drive. We'll see in figure 5-1 here of a typical CMOS setup screen, where we see the system date, time, the boot sequence can be set, the power settings, and it can be modified. So the bootstrap process, it's information contained in ROM. It's going to tell the computer, it's how the computer accesses during startup. It tells the computer how to access the operating system and the hard drive in the bootstrap process. All right, disk drives are made up of one or more platters that are coated with magnetic material. Some different components include the head, the track, cylinders, sectors. And we take an example, look at an example here of the platter. You see we have a read-write head, multiple platters in this hard drive. Now each platter each one of these concentric circles is called a track. This wide wedge-shaped area is called a sector. And each combination of tracks form a cylinder. All right, so these are going to be stacked on top of another platter. So example here, we've got this disk platter. The tracks has got 63 different sectors with 32 read-write heads, which gives us 1,024 cylinders, which gives us a total of 2,064,384 sectors. Okay, you got 512 bits per sector, so this gives us 1.056 gigabytes. Now the properties that are going to handle the drive's hardware firmware include the zone bit, recording, track density, array density, and our head and cylinder skew. The zone bit recording is the method most manufacturers use to deal with a platter's inner tracks being shorter than the outer tracks. By grouping the tracks by zones, that ensures that all tracks hold the same amount of data. Track density is the space between tracks on a disk. The smaller the space between the tracks, the more tracks on a disk. Now, older drives with wider track densities allowed the head to wander. The array density is the number of bits per square inch of a disk platter. And the head and cylinder skew, that's a method manufacturers use to minimize lag time. Okay, the starting sectors of a track are slightly offset from each other to move the read-write head. All flash memory devices are going to have a feature called wear leveling. That's an internal firmware feature used in solid-state drives that ensures even wear of read-writes for all memory cells. Now, this is the purpose of shifting data from one memory cell to another so that each one wears down evenly. Now, when you're dealing with solid-state devices, you make a full forensic copy as soon as possible. This is crucial. Okay, you do this in case you need to recover data from unallocated disk space. Now, the solid-state drives, they have internal power source for memory cells so that they can preserve the data. This is for both allocated and unallocated spaces. When working with mobile forensics, mobile device forensics, this feature is something that's very important, especially if the suspect was to delete relevant messages. All right, so for example, just before, if they get their device and they're able to delete the messages right before the device was seized and taken as evidence. We're looking at Microsoft file structures. The sectors are going to be grouped to form clusters. Storage allocation units composed of a group of sectors. And the clusters are going to be 512, 1024, 2048, or 4096 bytes each, for example. Now, cluster range can go from 512 bytes up to 32,000 bytes each. And what this does is combining these sectors minimizes the overhead of writing or reading files to a disk. The clusters are going to be numbered sequentially, starting at 0 in an NTFS or 2 in a FAT. The first sector of all disks contains a system area, the boot record, and a file structure database. OS are assigned these cluster numbers. OS assigns these cluster numbers, which are referred to as logical addresses. Sector numbers are referred to as physical addresses. And then clusters and their addresses are specific to a logical disk drive, which is it's called a disk partition. All right, a partition is a logical drive. Now, Windows operating system can have 3 primary partitions, followed by an extended partition that contain 1 or more logical drive. The partition can be an entire disk, or it can be part of a drive. Hidden partitions are voids. These are large unused gaps between partitions on a disk. Now, partition gap That's the unused space or void between the primary partition and the first logical partition. Now, one way to use or to partition a physical drive is to use a disk editor such as WinHex or Hex Workshop. This task is going to involves analyzing key hexadecimal codes that the operating system used to identify and maintain the file system. So if we look at figure 5.4, this will show us an example of a master boot record. The partition table is going to be in the master boot record. And it's going to be in a hexadecimal editor, as you'll see the different options here of where the master boot record is. The master boot record, this file contains information about partitions on the disk and their location, their size, and other important other information about the files. So when we examine the FAT disk, the file allocation table, it's a file structure database that Microsoft designed for floppy disk. The FAT database is typically written to a disk's outermost tracks and contains file names, directory names, dates, timestamps, starting cluster number, and the file attributes. The cluster size varies according to the hard disk and size. There are some variations of the FAT system. We have FAT12, FAT16, FAT32, EXFAT, VFAT. When we look at the FAT disk, we can see the drive size of the disk, the sectors per cluster, and then how it will be listed on the FAT16. So cluster size is going to vary according to the hard disk size and the file system used. Microsoft operating systems allocate disk space for files by clusters. This practice results in drive slack, which is unused space in the cluster between the end of an active file and the end of a cluster. It can contain deleted files, deleted emails, file fragments. Drive slack is made up of both file slack and RAM slack. File slack is the unused space created when a file is saved. If the allocated space is larger than the file, the remaining space is slack space. It contains passwords, login IDs, file fragments, deleted emails. RAM slack is the unused space at the end of the file, between the end of the file and the end of the last sector used by the active file in the cluster. Any data that resides in RAM at the time the file is saved, such as login IDs or passwords, can appear in this area. Okay, this is something that can be there whether it's saved or not. RAM slack is found primarily in older Windows Microsoft operating systems. We see an example here of file slack space. You see the RAM slack space here, file slack. All right, so when you run out of room for allocated cluster, the operating system allocates another cluster for your file. And as the files grow and require more disk space, assigned clusters are chained together. This chain can be broken or fragmented. So the operating system stores the data in a FAT file system. It assigns a starting cluster position to the file. The data for the file is written to the first selector of the first assigned cluster. Now, when this first assigned cluster is filled and runs out of room, the FAT system assigns the next available cluster to the file. If the next available cluster isn't continuous to the current cluster, the file then becomes fragmented. So we see an example here of a Word 2003 document and the clusters, the chain sectors. So we just discussed about this becoming fragmented. All right, in the FAT file system, when a file is deleted, the directory entry is marked as a deleted file with a hex E5 character replacing the first letter of the file name. And the FAT chain for that file is set to 0. The data in the file remains on the disk drive. The area of the disk where the deleted file resides becomes unallocated disk space. This space is now available to receive new data from newly created files or other files needing more space. So when an item becomes part of the unallocated disk space, the unallocated disk space is a partitioned disk space that isn't allocated to a file. It may contain data from files that have been deleted previously, so that's stuff that can still be recovered at this point. The NTFS, the NT file system, that's the file system Microsoft created to replace FAT. It uses security features, allows smaller cluster size, uses Unicode, but makes it a more versatile system. It's used mainly on newer operating systems, started with Windows NT, and it is the primary file system for Windows 10. Some improvements over a FAT file. It does provide more information about the files. It does give more control over files and folders. And it was Microsoft's move towards a journaling file system. So it records a transaction before the system carries it out. The NTFS, in this system, everything's written to a disk considered a file. So in this, the NTF disk, the first data set is the partition boot sector. The next is the master file table. The partition boot sector, that's the first data set on the NTFS disk. Starts at sector 0 of the disk drive, and it can expand up to 16 sectors. The master file table, that's what the NTFS uses to store and link files. It's a database that contains information about access rights, dates and timestamps, system attributes, and other information about the file. It does use NTFS results in much less file slack space. The clusters are smaller, so it makes smaller disk drives. The NTFS also uses Unicode, which is a character code representation that replaced the ASCII. It's capable of representing more than 64,000 characters in non-European based languages. See an example here of an NTFS disk, sectors per cluster, cluster size, and how that's related to the drive size. The NTFS system files, okay, the master file table, that contains information about all the files on the disk. That includes the system files the operating system uses. The first 15 records are reserved for system files, and records in the in the MFT are called the metadata. That's a term that refers to the information stored there. You see some example here of some file names, the system files, record position, and then their descriptions. So the first name, that's MTF file. It's base file record for each folder on the NTS volume. The second one has the first four records of the MFT. They're going to be saved in that position. Now, in this one, if a single sector fails in the first MFT, the records can be restored, allowing recovery of that master file table. Next, we'll move into the log file, where previous transactions are stored to allow recovery after system failure. And then finally into the volume. That's information that's specific to the volume, such as label and version. Some other records that were stored include the attributes definitions, the boot sectors, bad cluster files, security files, and then their descriptions of these as well. All right, so all files and folders are stored in separate records of 1,024 bytes each in an NTSF MFT. Each record contains a file or folder information, and that information is divided into record fields containing metadata. A record field is referred to as an attribute ID. And files and folder information are typically stored in one to two ways in the MFT record, either resident or non-resident. Now the attribute ID, that's the record field containing metadata about the file or folder, and the file's data or links to the file's data. All right, files that are larger than 512 bytes are stored outside the MFT. An MFT record provides cluster addresses where the files is stored on the drive's partition. These addresses are referred to as data runs. Each MFT record starts with a header identifying its resident or non-resident attribute. Data runs are cluster addresses where files are stored on the drive's partition outside the MFT record. Data runs are used for non-resident MFT file records. So looking at table 5-5, in here we can see that the record attribute ID and the purposes for those. We'll continue up with 5-5 here. Looking again at this attribute ID followed with their purpose. Figure 510 shows you a resident file within an MFT record. And you'll notice, for example, F is start the attribute of 0 times 40. When you look back into your attributes, you can find a 0 times 40 and see what the purpose of that file is. All right, so when a disk is created in NTF file structure, the operating system assigns a logical cluster to the entire disk partition. These assigned clusters are called logical clustered numbers, or LCNs. They become the address that allows the MFT to link to non-resident files on the disk partition. Now, I said the logical cluster numbers, that's numbers that the MFT, they use that to refer to a a specific location, physical location in a disk partition. We're also going to look at the concept of virtual cluster numbers. Virtual cluster numbers, that's when a large file is saved in NTFS, it's assigned a logical cluster number specifying a location of a partition. Large files are referred to as non-resident files. If the disk is highly fragmented, the virtual cluster number, the VCN, are assigned and list the additional space needed to store the file. The LCN is a physical location on an NTFS partition. VCNs are offset, or the offset of previous LCN data run. So when the data is first written to non-resident file, an LCN address is assigned to the file, and that becomes the file's virtual cluster number. Now we see the header of these. The first sector of MTF record is the header, and it's going to define the size and starting position of the first attribute. Now, these headers are attributes of the specific for that file type. So we look at the figures of 513. We can see we have an MFT record identifier, the record length of the record header, and this here is the updated sequence array. So this data goes into a position offset, i.e. IF. Size of the entire MFT record. See the create and date time, the last access time, as we're looking in the attribute O, 0 times 10. See the attribute ID, last modified date, size. Look at here is more information about this is the 0 times 30, short and long file names. 040 times 40, the object ID. This is the data for a resident file. And a continuation of data for a resident file as well. All right, alternate data streams are ways data can be appended to existing files. Data streams can obscure valuable evidentiary data intentionally or by coincidence. In the NTFS, alternate data streams became additional file attributes and allow the file to be associated with different applications. You can only tell whether a file has a data stream attached by examining the file's MFT record entry. So we see in figure 5-24, we have the start of the data run for the second attribute. See the second attribute here is 0 times 80. Size of the second attribute as well. NTFS provides compressions similar to the FAT Drive Space 3, which is a Windows 98 compression utility. With NTFS, you can compress files, folders, or entire volumes. Now, most computer forensics tools can uncompress and analyze compressed Windows data. The encrypting file system, this was something that was introduced in Windows 2000. It is a public private key encryption that was first used in Windows 2000 on NTFS formatted disks. The file encryption is encrypted with a semantic key, and then a public private key is used to encrypt the symmetric key. So the public and private keys, as you know from previous courses, private key, that's used to decrypt the file. The file owner keeps the private key. Public key is used to encrypt the file. It's held by a certificate authority, maybe a global registry, network server, or a company such as VeriSign. Now, when EFS uses Windows 2000 or later, recovery certificate is generated and can be sent to the local Windows administrator account. Users can apply EFS to files stored in their local workstations or a remote server as well. Recovery certificate, that's a method NTFS uses so that a network administrator can recover encrypted files if the file's user or creator loses his private key encryption code. Which brings us to the recovery key agent. This implements the recovery certificate, which is in the Windows administrator account. Windows administrators can recover a key in two ways. You can do it through Windows or from a command prompt. We have a couple commands in here. We have cipher or copy, how a key can be recovered. Also, when a file is deleted in Windows NT or later, the operating system renames it, moves it to the recycle bin. Another method is using the delete MS-DOS command. So this method eliminates the file from the MFT listing the same way a FAT command does. Resilient file system. This is Microsoft's newest file system, or new file system. It was introduced in Windows Server 2012 and was designed to address very large storage data needs, such as cloud storage. Some of the features of the resilient file system includes that it maximizes data availability, improves data integrity. It's designed for scalability, so it does allow increased scalability for disk storage. It does have better data or improved features for data recovery and error checking. Now, in the recent years, we've seen more concern about the loss of personal identification or personal identity information and trade secrets that can be caused by computer theft. The personal identity information, that's any information we use to create bank accounts, credit card accounts, things such as your name, address, social security number, driver's license number. Now, one of the most particular concerns is the theft of laptop computers and handheld devices. Now, to help prevent this, software vendors, or help prevent the loss of information, software vendors now provide whole disk encryption. Whole disk encryption has the following tools: pre-boot authentication. You have full or partial disk encryption with secure hibernation, advanced encryption algorithms, key management functions. This tool, this encryption encrypts each sector of the drive separately. So many of these tools encrypt the drive's boot sector to prevent any efforts to bypass the secure drive's partition. Now, if you want to examine an encrypted drive, you must decrypt it first, which means you're going to run a vendor-specific program to decrypt the drive. Now, many vendors, they'll use a bootable CD or USB drive that's going to prompt for a one-time passphrase. That's a password used to access special accounts or programs that require high levels of security. This passphrase can only be used once and then it expires. Microsoft BitLocker. This is available with Vista Enterprise and Ultimate Editions, Windows 7, 8, and 10 Professional Enterprise Editions, and Windows Server 2008 and later. The hardware and software requirements to use BitLocker includes a computer capable of running Windows Vista or later, the non-home editions, a TPM microchip, user version 1.2 or newer, computer BIOS compliant with the trusted computing group, 2 NTFS partitions, and also the BIOS is configured so that the hard drive boots first before checking other bootable peripherals. Now, there are some third-party disk encryption tools, such as endpoint encryption, that are available. All right, the Windows Registry. The registry is a Windows database that contains information about hardware and software configurations, network connections, user preferences, and setup information, and also other critical information. There's a couple of different ways you can view the registry. You can use the regedit program for Windows 98 systems, regedit 32 for Windows 2000 XP and Vista, or you can use both utilities for Windows 7 or 8. Now, for investigative purposes, the registry can contain valuable evidence. These are some of the terminology you should know for working with the registry. Looking at some of the file name and locations, and then the purpose of these files. For example, the security.dat contains the computer security settings. Software.dat is the installed program settings, associated usernames and passwords. When you use a registry editor, this is an example of the registry editor screen. Okay, the H key class root. Okay, that's a symbolic link to the local machine software classes. Provides file type and file extension information, URL, protocol, prefixes, and so forth. The H key current user. It's a link to the H key users. And there it stores the settings for the currently logged on user. Local machine contains information about installed hardware and software. The H key user stores information about the currently logged on user. Only one key in that H key is linked to the current user. Current configuration, or current config, is a link to the local machine system. Current control set hardware profile, VXXXX, where that is representing the current hardware profile. The last one, the H key DYN data, stores hardware configuration settings for the Windows 98, 95, and ME systems. Can we see some examples here of some different tools that have built-in or add-on registry viewers, such as OS Forensics, FTK? So in this example, they are entering a search term, searching through the registry. Pull this up a little bit. as they're looking for the search file for Outlook.com. They're looking in the keys, the values, the data. All right, so you need to learn what files are accessed when Windows starts. This information helps determine when a suspect's computer was last accessed, which is particularly important on computers that might have been used after an incident was reported. So start up in Windows 7, 8, and 10. 8 and 10 are multi-platform operating systems, so they can run on desktops, laptops, smartphones. The boot process uses a boot configuration data store. That boot configuration data contains the bootloader that initiates the system bootstrap process. So you press F8 or F12 when the system starts to access the advanced boot options. All NTFS computers perform the following steps when the computer is turned on. They perform a power on self-test, the initial startup, the bootloader, hardware detection and configurations, kernel loading, and then the user logon. So when Microsoft developed Vista, it updated the boot process to use the new extensible firmware interface, as well as the older BIOS systems. In this, the NT LDR program in Windows XP that's used to load the operating system is replaced with these boot utilities, the boot manager, WinLoad, and WinResume. When you start a Windows XP NTF workstation, several files are accessed immediately. The last access date and timestamp for the files changed to the current date and time. Okay, this change destroys any potential evidence that shows when a Windows XP workstation was last used. These are the startup files for Windows XP. The file systems for Windows XP. And I said, you know, when you start up Windows XP, it destroys any potential evidence as the date and timestamp are updated. Virtual machines enable you to run another operating system on an existing physical computer, which will be known as the host computer, by emulating a computer's hardware environment. Virtual machine will consist of several files. Virtual machine will recognize also the components of the host machine that's loaded on. The guest operating system is limited by the host computer's operating system. So we see an example of a virtual machine running on a host computer desktop. Now, in digital forensics, virtual machines make it possible to restore a suspect's drive on your virtual machine and run non-standard software the suspect might have loaded. From a network forensic standpoint, you need to make sure that be aware of some of the potential issues, such as virtual machines used to attack another system or network. Some common applications that we use for creating a virtual machine include VMware Server, VirtualBox, Microsoft Virtual PC, along with some others. VirtualBox is a open source program. You don't have to do any of the work installing a VirtualBox. All your assignments will be on MindTap. All right, so for Chapter 5, we looked at the boot records, what happens when the computer starts up. We looked at the different types of file systems that Microsoft uses, both the NTFS and the FAT. And we looked at the different types for working with the registry and virtualization with the virtual software.